last video, we looked at some more historical navigation techniques. In the timeline of navigation, we're now almost up to present day, and we're at a major development: satellite navigation.
You probably take for granted how easy it is to know which way to go nowadays, with the use of map apps on your phone. But it took some huge feats of technical innovation to get us here.
After Sputnik was launched in 1957, the transit system of 7 satellites was set up over the next few years, and ready to use by 1962. Taking measurements from 3 satellites could give location accuracy anywhere in the world to about 25 meters, and it worked at sea too.
This is roughly how modern satellite navigation works, albeit with many more satellites to get readings from. It relies on the massive triangulation, just like we talked about in that first video about compasses.
GPS, or Global Positioning System, was developed by the US government. It was developed for military reasons, but nowadays is free to use by anyone with a GPS receiver, like your mobile phone. It works without phone or internet signal. So long as your receiver has an unblocked line of sight to 4 or more satellites, it can tell you where you are and what time it is.
It uses trilateration, which we also mentioned in the video. To recap, we know the speed of radio waves, and we can measure the time it takes for the signal to get from the satellite to the receiver. So, we can therefore work out the distance to the satellite. Do this with 3 satellites, and you can pinpoint where you are. The 4th satellite is used to check that the time on all the other satellites is accurate.
The US's GPS is made up of 24 satellites and has been available for civilians to use, including on commercial flights, since the 1980s. The EU has its own version called the Galileo Positioning System, and lots of other countries around the world have their own too, such as India, Russia, China, and Japan.
You can see that space is looking quite messy these days. It's all thanks to computer programs and some key maths that satellites stay in their own orbits and don't all crash into each other.
Thankfully, only twice in history so far have 2 artificial satellites crashed into each other by accident. The most famous of these happened in 2009, when a US and a Russian communications satellite crashed into each other, completely destroying both satellites and creating thousands of pieces of debris. And without satellites, we wouldn't have GPS, but satellites are also useful for a whole range of other things, like collecting data about the climate and the weather, transmitting communications like television and internet, and for collecting high-quality images of space without the interference of our atmosphere. And as of the 1st of January 2021, there are 7,389 satellites currently orbiting Earth, though not all of these will be active.
But how do satellites stay in space, and what happens when they are deactivated?
Well, we'll start with how they stay in space. Essentially, they are in a constant state of falling towards the Earth. And the reason they don't fall back to Earth or shoot off into outer space is that they are traveling at the exact right speed to balance the force of gravity pulling on them. If they go too slowly, they will be pulled closer and closer to Earth before re-entering the atmosphere. If they go too quickly, they will completely escape Earth's gravity and fling out into space. The closer to Earth the satellite is, the faster it has to go to balance out the stronger gravity.
When a satellite comes to the end of their life, they can do one of 2 things. They can either be slowed down enough that they start to re-enter the Earth's atmosphere and burn up because it gets so hot, or they can adjust their orbit into something called a graveyard orbit, further from Earth, where inactive satellites continue to circle out of the way of active satellites.
So, that's a bit about satellites and how we use them for navigation, among other things. Have a go at the activities now, and join us back here for the final video, where we'll take a look at the timeline of all of navigational history.